Hello everyone, welcome back to our decentralized exchange part 3. In this part we are going to test our smart contract. So let's go and let me give you a quick recap of previous parts. Uh, we built the main RESKDEX smart contract, which is like Uniswap like DEX smart contract, where we implemented some advanced functionalities like create pool. We have add a liquidity function. We have remove liquidity, and the most important swapping functionality we implemented following some of the best gas optimize and security practices. And in this part we are going to test our smart contract. We will test everything. We will write some of the bad dust test. I will show you some of the best test practices, how you can uh, test smart contracts using Foundry. So let's go ahead and let's first create a new directory inside the source. Let's name it mock, and inside that mock let's create a new file, uh, mock erc 20.sol. And if you remember, sorry, uh, if you don't know, we are going to build ERC20 smart contract here. And if you don't know what is the ERC20 smart contract, how you can build, how you can deploy on Rootstock network, so make sure go back to I already created another tutorial for this. Go back and make sure watch this one. So let's go ahead and let's build our ERC20 smart contract here. So pragma solidity license identifier MIT, and let's use the same version from here, copy from here. Let's copy this from here. Let's go back here, pragma solidity, it's the same version. And let's import ERC20 from OpenJeplin. ERC20 smart contract, ERC20 from OpenJeplin contract slash token ERC20 dot sol. Let's make it mock ERC20. This is for testing purposes. Mock ERC20 for ERC20 is ERC20. Let's set up here our constructor, and inside that constructor let's make it ERC20 name and symbol. So mock ERC20. Let's first take a parameter here. What are these parameters? Let's say string memory, the name. Let's not make it underscore. Actually this is best practices, but let's not make it string memory symbol, and that's it. Now inside that ERC20 call, and let's pass this name, and let's go here and let's pass the symbol as well, and there we go. Thanks to, and now let's call the main function here, which is coming from, we are inheriting ERC20 smart contract from OpenJeplin library. And let's pass here message dot, let's call this main function which takes two parameters. Message dot, one is the address, so let's say message dot sender, and let's say we are minting 1 2 3 4 5 6 multiply, let's say 6 multiply, mm, let's say 10 to power 18. Now let's go ahead and create another function for the minting. So let's create a mint function here, function mint, and address of the two, which takes the two parameters and the amount. So let's int 256 amount, and let's make it external. So, and inside that let's call here the mint function. Let's copy this mint from here and paste here, and let's pass the 2 and the amount. Let's copy the amount from here, there we go. And what is this error, which is this error coming from? Actually, yeah, we forgot to add this here. and let's compile our smart contract. So we already compiled our smart contract in the previous part, the main part contract. So let's again compile for by running this command for build, and you can see our all the smart contracts are compiled successfully, compiling 4 files with Sol C version 0.8.13 and we are going to test in this part we are going to test, and in the next part I will show you how you can deploy our entire smart contracts, entire project on rootstock network. So let's go ahead and let's start testing our smart contract. So for that, this is for testing purposes we created the mock ERC20 smart contract. Let's close this, and let's go inside the test directory, and let's create a file. Let's name it rsk dex dot t dot sol, and let's start spdx, let's say pragma not. Let's copy this everything from here, spdx license identifier, and let's paste this here, and let's import test from forge standard library for the test from forge std slash test dot sol. There we go. And now let's import our main rxdx smart contract, as this is the smart contract we are going to test. So rsk dex from let's say dash dash src slash rxdx dot sol, and let's import our mock erc20 as well. With the help of mock erc20 we are going to test. So let's import this mock erc20 from dash dash src. I think there we have mock file, mock directory, and inside that we have mock erc20.sol. Now let's declare our testing contract. Contract rsk dex test is, let's make it test, and let's declare state variables here. So let's first copy the rsk dex, and let's make it public, and let's name it dex, and mock erc20, let's make it public, and let's name it token a, and the same the token b for, and let's declare some addresses here. Address public owner is equal to, let's say, address of this, and address, let's copy this address public, let's say what we can say, not alias, let's say user1, and address, let's say here 0x1, and the address of the public user2 0x2. And now we also have, I think, yeah, we need to declare here the pool id as well. So pool id, as if you remember, we have in bytes format. So let's make it public, and let's say pool id. Now let's set up our main function. So this is very important function we have to set up when you are testing your smart contract in Foundry, and which is always you should make it public. So its visibility is always in public, and inside that let's deploy our smart contract first. So to deploy, let's dex is equal to new rskdex rskdex, and inside that we don't have to pass any arguments or the parameters. Now let's deploy the token A is equal to new mock erc20 and new mock erc20, and let's name it token A, and we are not passing two parameters. We have to pass the here the symbol. Let's tka. If you remember, if you go back, and it is taking not here inside the mock, it is taking inside that constructor the memory, sorry, name and the symbol. So this is what we have to pass. So token A is equal to new mock erc20, and inside that the name of our, we are passing token A and the symbol is tk. The same with token B. Token B is equal to erc20 token B and tkb. Now we also need to create a pool here. So let's create a pool, and for that let's say pool id. If you remember, we declared here pool id, let's say is equal to dex dot, we need to pass the create pool contract, create pool, we need to call the create pool function here from our dex smart contract, and inside that we need to pass address of the token A and address of the token B. So let's go ahead, and it is taking only two, it is suggesting us anything. Copilot is confusing us, but we are not going to use copilot here. So let's pull it down, and we passed full id, we created the full id here. Now let's mint token to users. So for that let's mint tokens. You can see here token a dot mint, and we are passing user one, and this much the amount we are minting here. So token a dot mint user one, inside that we are passing and user two, user one, and user two, user two. So we mint token A and token B here. Now let's first test what we have to test. Create pool. Let's go back here. If you see, we have the function here. First create pool. So let's see user can create pool or not. To test this, let's start writing function test create pool, and let's make it public. So if you, this is the Foundry tip, if you are testing in Foundry, you should always start your function name with test, and your function visibility always should be in public. Remember, this is very important to remember. And now let's declare here bytes 32 expected pool id. Let's name it expected pool id is equal to now dex dot, we need to create get, I think pool id, get pool id. We have the function here, and inside that we have to pass the address of the token A and the address of the token B. And now let's assert equal a double assert assert equal, we need to pass the left side the pool id, and the right side we have to pass this variable we declare here. There we go. And now assert true, and inside that we have to pass the data dex dot pool exist. And if you remember, we have mapping, and inside that let's pass the pool id. I think, yeah, it is giving us warning of to view. to make it view. So don't worry, this is just warning. Now let's test whether create pool with identical tokens or not. So for that, let's go ahead, function test create pool with identical tokens. Thanks to Copilot, it is suggesting us, but we are not going to use what it is suggesting, identical tokens. And let's make it public. And now we are going to use here a foundry cheat code, expect reward, and it's inside that expected reward we need to pass the string here, identical tokens, identical tokens. Now let's go ahead and create a call a function, the create pool, and inside that let's pass address of the token A and address of the token A. Now let's go ahead, yeah, token A and token A. Let's go ahead and let's test if user can add liquidity or not. So for that, let's create a function test, add liquidity, add liquidity, and let's make it public. And this will be huge test here. So first let's let's use this cheat code here, freedom.start frank, and it takes an address here with, let's say, user1. And now let's declare two local variables here, int 256, amount A is equal to, let's say, 1000 multiply, let's multiply 10 to power 18, and amount B the same. Now let's say token A dot approve, we are using ERC20 smart contract. So inside that we have approve function, and which will take address of dex and amount A. Same go here, token B with token B address dex of the amount B. Now let's go ahead and let's create here int 256 actual amount A, actual amount A, and int 256 actual 256 actual amount B, and we also need to pass the liquidity. Let's take liquidity as well, liquidity, and it's equal to, let's say, dex dot, let's call add liquidity function here, and inside that how much parameters it will take, let's go here, dex is our add liquidity function. It is taking 1 2 3 4 5 6 parameters. So let's pass one by one here. So add liquidity, let's pass pool ID, and another one is here to amount A, amount B, and let's pass 0 0, and here let's say user1. We forgot to add the comma here. Let's format these documents. We also forgot to add this one here. And now let's go ahead and let's add three asserts here, assert equal, and left side let's pass actual amount A, and on the right side let's pass amount A. So where is amount A, amount A, amount? Let's pass this, copy this from here and paste here, and let's add another assert equal with actual amount B and the amount B, and inside the liquidity we need to pass here 0. There we go. Now let's go ahead and we need to pass I think we have not, we forgot to add here rank. Start rank is what the we need to pass. That's what I was thinking about. We are missing something here. What? Yeah, now here we go. Now let's go ahead and let's declare another here before stopping the prep. You int 256. Let's say reserves reserve A and reserve B, and is equal to, we need to call here dex dot get reserves. I think we have this same function here which takes the pool id thanks to copilot. And now let's pass assert equal reserve A, reserve and amount A, and reserve B, amount B, and let's stop ranking. Vm dot stop rank. There we go. So far we tested test create pool, test create pool with identical tokens, and now let's go ahead and let's say let's test add liquidity with ratio or not. So for that let's create function test add liquidity with ratio, and let's make it public. And now let's go and first let's first add initial liquidity. For that let's start vm dot start frank, and inside that let's pass user1, and let's go ahead and let's declare some local variables here. So initial amount, let's name it initial amount A, let's say is equal to 1000 to 10. Let's multiply this to 10 to power 18. The same with initial amount B. Now token A dot token A dot approve. We need to pass the address of the dex and initial amount A and initial amount B. Same here. Now let's call here dex dot add liquidity, and inside that we have to pass pool id initial amount A. So initial amount A, we need to pass also initial amount B, and here 0, amount B 0, and let's pass the user one here, which is the 6 parameters we have to give, and there we go. And we need to stop prank, vm dot stop prank, stop prank. There we go. Now let's go ahead now add liquidity with let's add liquidity with different ratio. For that let's start prank again, vm dot start bank, and let's pass user to that we declared here on top of user 2. Let's go and let's try with the different ratio. Let's declare u in 256 amount a is equal to, let's say, 500 multiply 10 to power 18, and this time amount b, let's say 2000. This should be adjust to, this should be like address to adjust to maintain ratio, right? Now let's say token a dot approve address of the dex and amount a and amount b. There we go. Now this time we need to pass here u into 56. Sorry, let's create a variable here. So actual amount a and actual amount b. For that, so let's say actual amount a and amount a u int 256 actual amount b, and let's say is equal to, let's call here add liquidity function, and we need to pass nothing. Let's call dex dot add liquidity, and inside that let's pass one by one pool id, amount a, amount b, and we also need to pass 0. There is 0, and this time we need to pass the user 2 here, and that's it. Now let's assert this, assert equal actual amount a, amount a, and actual amount b, thanks to Copilot. And let's pass let's stop ranking. So far we tested, I will show you, we just writing test first. The most important function now we have to test, which is the swap. It will take time, but just bear with me and I will show you. So far we have done not here. Let's test how our test goes by running forge test, and you can see here we have some failed test here. So yeah, don't worry, our one test is fast. We will dive into traces forge test dash vvv, and I hope so. You can see here inside the custom error in identical token. Let's go ahead forge test dash vvv, and you can see here what is happening exactly inside the traces. And even if you stuck anywhere, I am going to give you GitHub repo, so don't worry about this. If our tests are failing here, it will be passed. So let's pass here the, sorry, let's test our test swapping functionalities. For that, let's create a function, let's say test swap, and let's make it public. And let's first add some initial liquidity. Let's say start bank, and inside that let's pass user 1. Now let's go here and let's declare amount. I think we need to copy from this here, not actually. Let's go ahead. You went 256 amount a is equal to, let's say, 1000 multiply 10 to power 18. Now let's pass the, let's create a token a dot approve and token b for the same. And now let's add some initial liquidity. For that, and let's pass tx, let's call add liquidity function here, add liquidity, and inside that we need to pass amount a, first the full id, then amount a, copy the amount b, and 0 0 and user 1, 0 0 and share user 1. And let's stop ranking, vm dot stop rank. Now let's go ahead and let's perform a swap here. So we, let's say this is the same vm dot start frame, and inside that we are passing user 2. Now let's get a variable here, uint 256, and swap amount, let's name it swap amount, and let's go ahead. mm, what I am typing here, yeah, let's say, yeah, it is suggesting us same 100 or 1000, yeah, let's say 100. And now let's declare this one for the expected out. So let's expected out is equal to dex dot, we have function get amount out, and we need to pass three parameters here. Let's say swap amount first, and amount a and amount b. So let's copy this from here, amount a and amount b, there we go. Now let's approve token dot approve, and we need to pass address of the dex and the amount of swap amount. Token declared, did you mean token a? Yeah, we forgot to add the token a here. And now let's go and let's declare a variable here, 256, balance of balance b4 is equal to token b dot balance of, let's pass user 2 here, not the user 1. Let's close this. Now you int 256, let's say amount out, amount out, amount out is equal to dex dot, let's swap here, let's call the swap function here, swap, it will take the full id first and the address of the token a. File it is almost suggesting the same, but we need to pass swap amount here. Also we need to make it 0, amount out mean, let's make it 0, and the address, the last one is address 2. Sorry, we are where we pass the user to address. Now go ahead and balance b after, declare the another variable here, uint 256 balance b, let's say after, is equal to token b and balance of user 2. Thanks to cofile. Now let's assert equal, and on the left hand side we need to pass the amount out and expected out on the right hand side. Now let's add another assert equal here, and on the left side balance b after, balance b after. Let's minus this, balance b before, and on the right hand side amount out, whatever the amount going out, and that's it. Let's stop thanking. So far we built this. So I am giving you assignment. You write more test here, get test amount out, like you can test, we have the remove liquidity function here. I am going to give you all the source code and all the but just first start writing by yourself. I'm going to give you all the source code with in the description of this video, so don't worry. And this kind of assignment you can use. You can always go back to foundry documentation, and there you can find all the cheat codes you need to know. And I'm just giving you some uh, tips here, or the assignment kind of here. You can test uh, if like swap, if there is a insufficient liquidity, then user can do things or expect the logic we are having. And even you can test liquidity slippage here, and you can test like fee calculation working or not, and so on. And you can use a lot of foundry cheat codes, and that's it. Let's forge test again, and you can see here our include 3 failing tested. So this is also kind of assignment for you, and I will test it through rigorously, and I will give you source code, so don't worry about this if it doesn't make sense. And with that I am wrapping this this part here, and in the next part I will uh, in the next part I am going to show you how you can deploy this entire smart contract. Also, and I will write all the test as I said here, and I will show you how you can also write in the so stay tuned for next part, and I will see you there. Bye bye.